Welcome to Maths with EJD. In this video, we continue with the parametric tests, and here our focus is on one sample t-test. The one sample t-test, the one sample t-test is actually a statistical test. It's a statistical test to determine whether the mean of a single sample is significantly different from a single, significantly different from a known or hypothesized population mean. Okay, so here it's only one sample, right? And then you're comparing it with a population mean that you know. So this test is particularly useful when dealing with small sample sizes. Of course, seeing if large sample sizes are typically n greater than or equal to 30, then small sample sizes will be n less than 30. And of course, when the population variance is unknown, when the population variance is unknown. So if you compare this with Z-test, right? Z-tests are done when you have large sample sizes, n greater than or equal to 30, or when you know the population variance, which of course would mean that you also know the population standard deviation. So let's look at some assumptions of one sample t-test. Assumptions of the one sample t-test. Okay, the first one is independence of observations. Independence of observations. So each observation in the sample must be independent of the others. Okay, then number two, there is normality. So for normality now, the sample should come from a population that follows a normal distribution. However, the t-test is robust to violations of this assumption when the sample size is larger. And the sample size is larger. So the larger the sample size, the better also. Then we have the third assumption of the one sample test, and that is scale of measurement. Okay. So the data should be measured. Data should be measured on an interval or ratio scale. interval or ratio scale. Okay. So so this kind of thing will be good for things like temperatures or height and all of that, or weight and so on. Okay. So let's talk about the formula now. The formula, for one sample t-test, say that the test statistic for the one sample t-test is calculated using the formula. So it's very close to what you have for Z-test. The only difference is the largeness of the sample sizes, or knowing the variance or not knowing it. So that's X bar over mu divided by S over square root of N. And as usual, so X bar here is the sample mean. X bar is the sample mean. Mu is the population mean. Even if it is hypothesized. And then you have the sample standard deviation, or what you can call standard error. Sample standard deviation, that's the S. Sample standard deviation, or call that SE, standard error. And clearly N is the sample size. So that's how that goes. So let's look at the steps necessary for conducting this. So steps to conduct a one sample t-test. Okay. So the first step is the null. Is to state the hypothesis always, right? States the hypothesis. Okay. Here you have the null hypothesis, H naught. We are used to this already. So okay, let me just write it in full. Null hypothesis, or H naught. So this is simple. You just say that the sample mean is equal to the population mean. Or you can say there's no significant difference between the sample mean and the population mean. That's another way to say it. So this is just like saying H naught is such that X bar is equal to mu. Okay, that's the null hypothesis. Then you have the alternative hypothesis. That's your HA, or if you like, H1. So here, the sample mean is just negate the null hypothesis. So the sample mean is not equal. It's not equal to the population mean. It's not equal to the population mean. So that means HA is such that X bar is not equal to mu. So that's the first step, state the hypothesis. Then the next thing is number 2. Then you set the significance level as usual. Set the significance level, which is alpha, right? So of course, common choices are 0.05 if you want a 95% confidence level, or 0.01 if you want a 99% confidence level. Depends on your choice. Then we have the third one. The third step in the process will be to collect data. Of course, collect data. Most times you already even have the data you want to use. So you just obtain a random sample from the population, So this might be in the form of the data you have already collected when after administering your questionnaire also. So that works well. Then the fourth step is to calculate the test statistic. Calculate the test statistic. Okay. So here you use the formula above. Use the formula above to compute the t. Okay. Then you have number 5. You want to determine the critical value. Determine the critical value. That's what you get from the table. Determine the critical value. So in that case, that will be depending on the chosen significance level, on the chosen significance level, and the degree of freedom, and the degrees of freedom, which is, the degree of freedom is calculated as n minus 1, that's sample size minus 1. And you want to find the critical value from the t distribution table, So I'm silent about the table here because the tables vary. So you want to get used to a particular table. So here I just give you the value and move on, because the tables are not always the same. But of course, they will give you the same results. Like the way of checking will always be different depending on the table you're using. So then you have the decision rule, and there are two of them. If the absolute value of t, that's the test statistic, is greater than the t critical, that's the critical t you get. If the test statistic, the absolute value of the test statistic is greater than the critical value you get, right? You just reject H naught. So it must not exceed your calculated t should not exceed the critical t. Okay. On the other hand, if the absolute value of your calculated t is less than or equal to the critical t you get from the table. So usually whatever you get by calculation should be less than or equal to whatever you get from the table. So in that case, you fail to reject H naught. That means you accept H naught. Okay. So if what you calculate is greater than what you get from the table, that's reject H naught. So we move on to step 7, and that's where you make your conclusion. So make your conclusion. So here, based on the comparison, of the test statistic, and critical value, state whether you reject or accept the null hypothesis. Okay. All right. Now that we have all that, let's take an example to drive the point home. So a teacher believes that the average score of her class on a math test is 75. Then she goes ahead to she takes a random sample of 10 students and records their scores. So the scores are 82, 76, 71, 69, 80, 75, 78, 74, 79, and 83. So 10 students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right. So the key is we want to test if the teacher's hypothesis is correct or not. So we want to validate her claim. Now let's go for that. So the first thing is step one. Step one, we want to test her hypothesis. Step one, so you state the hypothesis. State the hypothesis. And that is simple. You have H naught. The null hypothesis is that what the teacher has stated, that the mu is 75, right? And the alternative hypothesis is that the mu is not equal to 75. Okay, that's the first step. Then second step, that's step two. Calculate X bar and S. That is the sample mean and the sample standard deviation. I want to calculate those. Of course, X bar is just going to be add up all these scores and divide by 10, basically. So you have 82 plus 76 plus 71 plus 69 plus 80 plus 75 plus 78 plus 74 plus 79 plus 83, 79 plus 83. Like that. All of this divided by 10. So that if you do that, X bar is simply 79.8. So that is X bar. So the next thing is the S. Basically, S is given as square root of the summation of xi. We've done this a couple of times, minus X bar all squared divided by n minus 1, being a small sample size. So that's what we have there. So in that case, I think it's always easier to make a table. If you make a table, things will work way better. So we have our xi's now. So there you have 82, 76, 71, 69, 80, 75, 78, 74, 80, 75, 78, 74, 79, and 83. Those are the 10 values. Then you need, of course, you already have X bar to be 79.8. X bar is 79.8. So we need Xi minus X bar in each case. So that means we have 82. So this is the deviation, right? Deviation is this. So that means you have 82. Okay, let me just make it in two layers. So we get the X bar. How do I do it now? Okay, yeah, we need X bar in short. So this is 82 minus 79.8. So we can put the answer here. That is 4.84. Yeah. Then maybe I should even use another color. Okay, I'll start doing that. So next you have 76 minus 79.8. And that is 14.44. Okay, no, that can't be correct. Um Okay. Yeah, 82 minus 79. That is actually 3. So 82 minus 79 is 3. Then minus 0.8. That is 2.2. Yeah, so this would be 2.2. I'm thinking, can we just do it straight? Okay, let's do it straight to save time. So what I'm just going to do is so normally we should subtract this first, but I just want to do the square straight. So we just get our answer and move on. Okay, so this is 82 minus 79.8 squared, and the result is 4.84 straight up. So next we have 76 minus 79.8 squared. So normally you should just subtract and get the answer, then you square later. So this will just be 14.44. 14.44. Then next we have 71 minus 79.8 all squared. You know, that's this x1 minus x bar squared there. So we have that should be 76.84. And we have 69 minus 79.8 squared. So that is 116.64. Then we have 80 minus 79.8. That is actually 0.2. 0.2 squared is 0.04. So this is actually this now. You can say this is d squared because this is simply deviation, all squared. Okay. So we have 75 minus 79.8 squared. So that is 22.84. And then you have 78 minus 79.8 all squared. So that will be something small again. That is 3.24. And then you have 74 minus 79.8 squared. Okay. That is 33.64. 33.64. And then we have 79 minus 79.8 all squared. That is something tiny, which is 0.64. And then lastly, we have 83 minus 79.8 squared. And that will be 10.24 when we subtract and square. That is 10.24. Okay, so we have all this now. We have all this. So that at the end of the day, we need the summation of all that. So we need the summation. So we need summation of xi minus x bar all squared. So when you add up everything here, you add up everything here, you get that's 302.6. 302, 302, 0.6. 302.6. Yeah, so 302.6. So that S now, yes, I want to change the color. S, which is again the square roots of the summation of xi minus x bar all squared divided by n minus 1 would be equal to square root of this whole summation is 302.6. N minus 1 is 10 minus 1. Okay, let me take that. 10 samples minus 1. So S now is square root of 302.6 divided by 9. And that is S, small s, approximately square root of 33.62. So S now is approximately 5.8. So that is That is our approximate value for the standard error, or what you call the sample standard deviation. So we have that. So next, now we have to calculate the test statistical to step 3. So step 3, calculate the test statistic. Okay, that's compute the test statistic. So that means our T now, because we know T from the formula, T is, let's see that again. Yeah, X bar minus mu over S divided by root N. Okay, so to calculate the test statistic now, so we have T equals X bar minus mu divided by S over square root of N. So that would be 79.8 and a 75 over 5.8, which is the standard error or sample standard deviation divided by square root of 10. So that T now will be approximately, when you subtract that, you have 4.8 divided by 5.8 over square root of 10 should be something like 1.83. So that T finally is approximately 2.62. So this is our test statistic. And then we go for the next step, step 4. So for step 4, you determine the critical value. This is where the table comes in. So the critical value is the value against which you compare your test statistic so you can make a decision. So determine the critical value. So for a two-tailed test with degree of freedom 9, 10 minus 1 is 9. Okay, well, let me just leave it this way. With degree of freedom 9 at alpha equals 0.04. If you check your table, so the critical t value, it used to be z value, now it is t value from the t distribution table, is approximately plus or minus 2.262. So you can check your table to be sure of that. So then we go for step 5 now. Step 5. So the critical value is this now. So step 5. So for step 5, we check the decision rule. Okay. So for the decision rule, here we see that the absolute value of the test statistic, statistic we actually got initially. Where is it now? Okay, we have 2.62. Interesting. So the test statistic is 2.62. That is absolute value of 2.62. That is simply 2.62. Then we now look at T critical. Since it's plus or minus, look at the plus side. So T critical is 2.262. Okay, so 2.62 and 2.262. So here we see that the absolute value of the test statistic is actually is greater, it's greater than the T critical. That's a critical value, which is 2.262. So in that case, since the calculated value is greater than the critical value, we have to reject, because for us to accept the null hypothesis, the calculated T has to be less than or equal to the critical T from the table. So here we reject the null hypothesis, So we see that there is sufficient evidence. There is sufficient evidence to suggest that the average score of the class is significantly different, from 75. So how do we conclude? So in conclusion now, so to conclude, we say in this case, the null hypothesis H naught, which is mu equals 75, is rejected. It's rejected based on the one sample t-test analysis. Okay, so this indicates that the teacher's belief, this indicates that the teacher's belief regarding the average score of a class is not supported by the sample data. As the sample mean of 79.8 is statistically significantly different from the hypothesized. You know, a belief is just like a hypothesis, right? From the hypothesized mean, of 75. So, yeah, so we see that that is how one sample t-test goes. So, when do you know to use sample? How do you know when to use sample t-test? Like we said already, don't forget you use it when you don't know the variance or when the population is small. So don't forget to subscribe to this channel, then hit the notification bell, so you can always get alerted when a new video is released. Then comment, let me know if you want to teach a particular topic. Then you can also let me know if you want me to solve a problem, then like. And of course, share so that more people can have access to all this learning. Okay? So we'll continue with other tests in other videos. Till then, have a nice time. Bye.